So, welcome today. We are going to discuss about the architectures of 8051. So, this is a microcontroller. 8051 apna, it is a microcontroller which is of 8-bit. So, before detailing about what 8051 is actually all about, it is important to learn about what is 8086. So, 8086 is a microprocessor that every one of us know. It is a microprocessor of 16-bit. And it has various registers like accumulator, base register, counter register and data register, and these are some general registers. Added to that, you have other segment registers as well. So this is added to that, we have also learnt about the external interfaces that can be interconnected with 8086. So again, I'll repeat, 8086 is a microprocessor that is of 16-bit, and it do have various number of registers, and all these registers are having 16-bit of storage. And now we have to shift to 8051. So 8051 is a 8-bit microcontroller. The main difference between a microprocessor and the microcontroller is the microprocessor will perform only the instructions given to it. When there is a power off or when there is any other external disturbances, the microprocessor cannot hold upon any data. So that is the biggest disadvantage of microprocessor. But microcontroller has an efficiency to proceed through the entire process even if there is any interruptions. So the main growth from microprocessor to microcontroller is the efficiency and improvisation of its performances. That is the first difference. And second difference is we are going to compare 8086 with 8051. So here you'll have a 16-bit of operations has been performed, but here in 8051 you'll have a 8-bit performances only, but it is found to be very efficient. 8051 is found to be efficient than 8086, that we'll be discussing in the forthcoming slides. And then the register, concerned about the register, 8051 consists of two major registers along with some special function registers. The major registers are A register and B register, which is going to perform the basic arithmetic operations of 8051. And you have other special function registers also been available for 8051. So this is the general introduction between 8086 and 8051. So talking about the features of 8051, it do have an interrupt facility. Like it do have an internal interrupt and also it do have an external interrupt. So two different types of interrupt can be accessed through 8051. And then it has a bit addressability technique and enhanced set of instructions. Wherein in 8086 you have a large group of instructions, but they are not found to be a as easy approach for an user. But instead in 8051 you have an enhanced set of instructions that can be utilized for various other applications, which also makes 8051 stands to be very unique from already existing sets of instructions. And obviously it is a powerful chip, and that is the reason 8051 has been manufactured by Intel in large number, and it is cost effective when compared to microprocessor. And it do have two different types of memory. One is program memory, the other one is data memory. So far as what we have learned is 8086, where we have been talking only about 1 MB of memory space. Only 1 MB of memory space, which is totally a combination of program memory and along with the data memory. But here instead in 8051 you have two different types of memory. The first memory type is program memory type, and second one is data memory type. So this type of difference in access towards your program and data memory is called as Harvard architecture. Okay, so 8051 follows hardware architecture, where 8086 follows von Neumann architecture. VONNEUMANN. Von Neumann architecture has been followed in 8086, and hardware architecture has been followed in 8051. So this is yet another difference that you need to keep in mind. Difference between hardware architecture and von Neumann architecture is an expected 2-mark question. It is an expected 2-mark question. So hardware architecture, you have a access of memory in two different aspects. One is program memory and data memory. The example of hardware architecture is 8051, wherein in 8086 you have a combination of memory, like one memory will be accessed for both program and data, and that type of memory access is called as von Neumann architecture. Example is 8086. So the next thing is we have to talk about the specifications of 8051, wherein you can expect all these things either in 1 mark or it can be another 2-mark question. So we have already discussed this, it is an 8-bit CPU, right? Wherein all the data that you're going to access will be in terms of 8-bit. Especially when you talk to your registers, you have to talk it in terms of 8-bit. But the input for 8051 is either again a hexadecimal value. So again 8051 will be accessing the data in the form of hexadecimal. It is a 8-bit data, and already it has been mentioned, since 8051 is following hardware architecture, it do have a program memory and it do have a data memory. So program memory is of 4 KB ROM, read-only memory, and data memory is of RAM, 128 bytes RAM, and you'll have 21 different types of special function registers. So SFR is nothing but special function registers. It is special function registers, and you have an external data memory and program space. The external data memory can be of 64 kilobytes, and address from program memory is also again 64 kilobytes. So this will be explained in detail when we are learning about the memory organization. And you will have two 16-bit timer and counters. So you'll have two different types of 16-bit timers and counters, and you totally have 5 different interrupt structures. 2, you have an external interrupt, and 3 will be an internal interrupt, and this is an important specifications of 8051 that we need to keep it in our mind. So talking about the next thing, it is the architectures of 8051. So it is a single chip. So obviously 8051 is a combination of different blocks, as what we have discussed so far. It do have everything built inside it, like interrupt, RAM, ROM kind of stuff. So it has been interrupted, it has been there in a single chip. So that is the first point. And then you have it consists of CPU, memory, which is an inbuilt part of it. In 8086, you have the processing units, you have your memory as an external interface, but here in 8051 all these things are on the same chip, and you have IO ports, timers and other peripherals, and also 8051 supports is for external interface, wherein வெளியிருந்து நீங்க components எடுத்துட்டு வந்து கூட இது கூட connect பண்ணிக்கலாம், but moreover it do have an architecture has been built inside it. And it consists of CPU. Obviously it is a processing unit by itself, it is a processing unit. It is of smaller in size, low power and low cost, and it is based upon hardware architecture. So hardware ஆர்கிடெக்சருக்கும் von Neumann ஆர்கிடெக்சருக்கும் என்ன டிஃபரன்ஸ் அப்படின்னா, ஹார்ட்வேர் ஆர்கிடெக்சரில் உங்களோட ப்ரோக்ராம் மெமரியும் டேட்டா மெமரியும் தனித்தனியாக நீங்கள் ஆக்சஸ் பண்ணியிருப்பீங்க. ப்ரோக்ராமுக்குன்னு தனி மெமரி, டேட்டாக்குன்னு தனி மெமரி. ஸோ அதுதான் வந்து ஹார்ட்வேர் ஆர்கிடெக்சர். ஸோ அந்த ஆர்கிடெக்சர் சிஸ்டம் தான் உங்களோட 8051 நம்ம ஆக்சஸ் பண்ணிட்டு இருக்கோம். பட் von Neumann அப்படின்னு எடுத்துட்டா 8086 சிங்கிளாக ஒரு 1 MB ஆஃப் டேட்டான்னு கொடுத்துருவோம். அதை ப்ரோக்ராம் மெமரியாகவும் வச்சுக்கலாம், இல்லை டேட்டா மெமரியாகவும் வச்சுக்கலாம், டிபெண்டிங் அப்பான் த சிச்சுவேஷன். ஸோ தட் இஸ் ஹவ் இட் ஒர்க். ஸோ 8051 is based upon hardware architecture. And there is no data corruption or loss of data. This is a key important point that you have to keep it in mind. Why? Because when there is a out of power condition for a microcontroller, the data will never be lost. For example, the best example for the microcontroller is your washing machine. So when you load your washing machine, say suppose if there is a power loss, if there is any power cut, then what will be the washing machine will be doing? It will be stop the process and it will resume the activity at the particular instant, and it will restart the ப்ராசஸ். இப்போ லோட் பண்ணி வச்சுட்டு சப்போஸ் கரண்ட் போயிடுச்சுன்னா என்ன பண்ணுவோம், எந்த இடத்துல மைக்ரோ கண்ட்ரோலர் ஸ்டாப் ஆச்சோ அந்த இடத்துல இருந்து உங்களோட ப்ராசஸ் கண்டினியூ ஆகும் வாஷிங் மிஷினில். ஸோ இட் இஸ் அ பெஸ்ட் எக்ஸாம்பிள் ஆஃப் மைக்ரோ கண்ட்ரோலர். ஸோ அந்த இடத்துல லாஸ் ஆஃப் டேட்டாவே இல்லை. ஸோ தேர் இஸ் நோ டேட்டா கரப்ஷன் ஆர் லாஸ் ஆஃப் டேட்டா கன்சர்ன் வித் 8051. And there are 3 different general types of memory you have, like internal memory, external memory, and you also have a internal memory, external data memory, and a special access to SFR. So that is important. Internal memory, external memory and SFR. So you have on-chip memory access, external code memory, and you also have an external RAM, external on-chip, external code memory, external RAM. So this is how it has been classified. And this is an architecture. The current picture that is available on your screen is the architecture of 8051. 51. So the first thing is external interrupt. So as what has been already mentioned, it consists of two different types of external interrupt. Added to that, you have to include this arrow marks. It consists of three internal interrupt. Two external interrupt and three internal interrupt will be there, and you will have a center processing unit and oscillator to retain the clock frequency, and ROM, read only memory of 4 kilobytes, and 128 byte RAM. You have two different types of timers and counters, and serial ports have been there for accessing the communication happens, and input output ports, which is of 4 different types. There are 4 different ports has been available, and you have a bus control. The different types of bus control has also been available. So the main advantage of having 8051 is you have to have an external blocks in 8086 rather than in 8051. You always have all the components has been combined together in a single block. So that is a major advantage of having 8051. So here talking about the instruction cycle of 8051, there are 6 states for contributing for one instruction cycle. So for one instruction cycle you have 6 states: state 1, state 2, state 3, state 4, state 5 and state 6. So each state it consists of 2 pulses: pulse 1, pulse 2, pulse 1, pulse 2, pulse 1, pulse 2. Similar way it goes on. So one instruction cycle consists of 6 states and each state consists of 2 pulses. So this is the instruction cycle of 8051. So I just want to summarize till this what we have learned. First we have started with what is the comparison between 8086 and 8051. Then I've told you what 8051 is actually all about, the advantages of 8051, and then we have learned about the architectures of 8051 in comparison with 8086, and then the instruction cycle of 8051. Added to that, we have also learned about the features of 8051. So this is one important 16-mark question that you've been expecting in your university or your internal examination. Then this is a power saving mode. The most important point that every one of us note in 8051 is the power saving mode. The first mode is ideal mode and the second mode is power down mode. See, in ideal mode, even if there is a power cut, the data will be stored. Okay, but suppose in power down mode, if it has been activating, there is no data will be stored. That is a major difference. So ideal mode, when the CPU is turned off, RAM and on-chip unit remains active. So that is the first point you have to keep in mind. So ideal mode, you have your RAM, on-chip units, remain active. Whereas in power down mode, all on-chip activities are suspended. So all on-chip activities are suspended. So ideal mode, and this is a power down mode. So with this we have came to an end of learning architectures of 8051. So the second half of this video is regarding the memory organization of 8051, which is yet another an important topic because without knowing the memory organizations of any processor or controller, it is hard for us to code it up. So that is how it works. So we totally have 64 kilobytes of program memory. We have 64 kilobytes is of program memory, and also we have 64 kilobytes of external data memory. Okay, so since it has been following hardware architecture, the memory is divided into program memory and data memory. So program memory is of 64 bits and data memory is also 64 bytes, and it's also about 64 bytes. Right, then we'll have so now if I want to talk about the program memory, so that is the first condition. So when I want to talk about program memory, it will be of 64 kilobytes as what we have learned so far. It is of 64 kilobytes, and it will also have 4 kilobyte of on-chip ROM. Okay, so program memory is of two different types. You have 64 kilobytes of program memory along with 4 kilobytes of on-chip memory. Now the question is, when you are dealing with 8051 microcontroller, how will I conclude which part of the memory did I am accessing with? For example, if I'm writing a code, which part of the memory has to be accessed? That is the biggest question. So for that, we shift to a pin called EA pin. Okay, so if this EA pin is found to be low, if it is found to be low, then we are accessing the external memory. If it is found to be low, we are accessing the external memory that starts from 000 and it ends with FFFH. So it is like we'll have an hexadecimal range of operations. So EA pin, if it is found low, it will be activated, it will be using the external memory. Suppose if you find your EA pin to be high, if it is found to be high, which means it is active enough, then it will be accessing the internal ROM. It will be accessing the internal ROM. So this is how the program memory access. So program memory எடுத்துக்கிட்டிங்கன்னா ரெண்டு மேஜர் பார்ட்ஸாக நீங்கள் டிவைட் பண்ணிக்கலாம். ப்ரோக்ராம் மெமரிக்கு டோட்டலாக 64 கிலோபைட்ஸ் ஆஃப் ஸ்பேஸ் நம்ம ஆக்டிவேட் பண்ணியிருப்போம், ப்ளஸ் 4 கிலோபைட்ஸ் ஆஃப் ஆன் சிப் ரோம் ஆக்டிவேட் பண்ணியிருப்பாங்க. இப்போது நம்ம ஒரு கோட் நான் எழுதுறேன் அப்படின்னா இந்த பார்ட் நான் ஆக்சஸ் பண்ணிக்கிறேன், 64 கிலோபைட்ஸ் நான் ஆக்டிவேட் பண்ணியிருக்கேன்னா இல்லை 4 பிட் வந்து என்னோட கண்ட்ரோலர் ஆக்சஸ் பண்ணியிருக்கான்னு என்னால் கண்டுபிடிக்க முடியாது. ஸோ அது எந்த ஆக்சஸ் நான் எடுக்கணும் அப்படின்னு எப்படி என் கண்ட்ரோலர் டிசைட் பண்ணோம்னா இந்த EA பின் வச்சு தான் டிசைட் பண்ணும். இப்போ இந்த EA பின் லோவாக இருந்தது அப்படின்னா நான் என்னோட எக்ஸ்டர்னல் மெமரியை ஆக்சஸ் பண்ணிக்கலாம், இல்லை என்னோட பின் ஹையாக இருந்ததுன்னா இன்டர்னல் மெமரியை ஆக்சஸ் பண்ணிக்கலாம். ஓகேங்களா? ஸோ திஸ் இஸ் ஹவு த ப்ரோக்ராம் மெமரி ஒர்க்ஸ். ஓகே, அண்ட் ஆல்சோ டு மேக் இட் வெரி ஸ்பெசிஃபிக், இங்கே லோ அப்படிங்கிறது வந்து EA pin be equal to 0 and here you have your EA pin will be equal to 5 volt. So this is how it will be accessed. Okay, and the second thing is data memory. We are very very conscious about this. Again, data memory is of 64 kilobytes. Inga vandu you will have a 64 kilobytes of external data memory. Ina 64 kilobytes of external data memory irukum. Added to that you have 128 bytes of internal data RAM. It will be acting as it will have a internal data RAM, and added to that we'll have 21 different types of special function registers. Okay, we do have a special function registers. Inge we want to add few more points to this. So when I want to access this external data memory, the controller will be giving me either a 8-bit of address or it will be giving a 16-bit of address. ஏன்னா நான் டேட்டாவை ஆக்சஸ் பண்ணணும், டேட்டாவை நான் ஸ்டோர் பண்ணணும், இல்லை டேட்டாவை வந்து நான் ரிட்ரைவ் பண்ணணும் அப்படின்னா either I can use with external data memory or internal data RAM, இல்லைனா I can use either 21 SFR registers. When registers have been given to you, it is important that you have to have an address. ஓகே, ரெஜிஸ்டர்ஸ் அப்படின்னு நம்ம பேசினாலே நமக்கு என்ன இருக்கணும், அட்ரஸ் இருக்கணும். இந்த அட்ரஸ் ஒன்று 8 பிட்டாக இருக்கலாம், இல்லை 16 பிட்டாக இருக்கலாம். அதுதான் மேஜராக இந்த டேட்டா மெமரியில் நீங்கள் ஞாபகம் வச்சுக்க வேண்டியது. செகண்ட் ஒன் வந்து 128 பைட்ஸ் நமக்கு இன்டர்னல் டேட்டா ரேம் அப்படின்னு கொடுத்துட்டாங்க. ஸோ அப்போ இதை ஆக்சஸ் பண்ணுறதுக்கு எனக்கு 8 பிட் அட்ரஸ் இருந்தால் போதும். ஓகே, ஸோ ஐ ரிப்பீட், ரெண்டு டிஃப்ரெண்ட் டைப்ஸஸ் ஆஃப் மெமரி நமக்கு இருக்குது. ஒன்று டேட்டா மெமரி, இன்னொன்று ப்ரோக்ராம் மெமரி. ப்ரோக்ராம் மெமரி அப்படின்னாலே நம்ம ரோம் தான் பேசிகிட்டு இருக்கோம். அந்த ரோம் ப்ளஸ் 64 கிலோபைட்ஸ் ஆஃப் ப்ரோக்ராம் மெமரி, இந்த ரெண்டில் எது வேணால் நீங்கள் ஆக்சஸ் பண்ணிக்கலாம். இதில் எது ஆக்சஸ் பண்ணுறது அப்படின்னு மைக்ரோ கண்ட்ரோலர் எப்படி டிசைன் பண்ணணும்னா என்னோட EA பின்னை வச்சு தான் டிசைன் பண்ணும். பட் டேட்டா மெமரி அப்படின்னு எடுத்துக்கும் போது எனக்கு 2 டிஃப்ரெண்ட் டைப்ஸ் ஆஃப் டேட்டா மெமரி எடுத்தாச்சு. எக்ஸ்டர்னல் டேட்டா மெமரி, இன்டர்னல் டேட்டா மெமரி. எக்ஸ்டர்னல் டேட்டா மெமரி எவ்வளோ பைட்டு 64 கிலோபைட்டு. அப்போ அந்த டேட்டா மெமரியை நான் ஆக்சஸ் பண்ணோம், எனக்கு என்ன வேணும், அட்ரஸ் வேணும். ஸோ அந்த அட்ரஸ் எய்தர் 8 பிட்டாகவும் இருக்கலாம், இல்லை 16 பிட் அட்ரஸாகவும் என்னோட கண்ட்ரோலர் எனக்கு கொடுத்துரும். இன்டர்னல் டேட்டா மெமரின்னு எடுத்துக்கும் போது மொத்தம் 128 பைட்ஸ் அதுக்கு இருக்கும். அதை நான் ஆக்சஸ் பண்ணுறதுக்கு எனக்கு 8 பிட் அட்ரஸ் போதும். ஓகேவா? ஸோ டோட்டலாக இங்கே வந்து இன்டர்னல் டேட்டா ரேம் அப்படின்னு எடுத்துட்டா இட் கன்சிஸ்ட் ஆஃப் 256 லொக்கேஷன்ஸஸ். டோட்டலி யூ ஹேவ் 256 locations இருக்கும். This can be divided into two parts, lower part and upper part. So lower 128 and upper you have another 128. So lower 128 அப்படிங்கிறது it starts from 0 to 127, wherein upper அப்படிங்கிறது starts from 128 to 255. 5. Okay, all these upper part of your locations will be accessed through SFR, special function registers, wherein this lower part will be accessed through on-chip memories. We'll be accessing it with on-chip memory. So this is how it works. Okay, so totally we have 256 locations. It has been divided into lower part 128, upper part 128. Lower part starts with 0 to 120. 0 to 128, and upper part it starts from 127. Okay, and here it starts with 128 to 255. So upper part can be accessed through SFR and lower part can be accessed through on-chip memory space. So that is how this diagram details about the RAM area and ROM area. So this is ROM memory space, and this is RAM, and this is SFR. Okay, so special function registers are there, RAM, and also we have ROM has been available. So the major major memory organizations have been given here. You have different 80 general purpose registers, 16 addressable registers, and 4 bank. Okay, so these 4 bank, so this part, direct and indirect addressing mode is nothing but they are data memory. Okay, they are data memory, and this is an external memory space. This is an external memory space, and there are additional memory can be given for your program memory space, right? So here this bank 0, bank 1, and bank 2 and bank 3 can be accessed through program status word, PSW. The next slide I'll be explaining about what program status word is actually all about. சரியா? So மொத்தமாக நம்மக்கிட்ட இருக்கிறது 3 different types of memory space. ஒன்று டேட்டா, ஒன்று எக்ஸ்டர்னல், இன்னொன்று வந்து ப்ரோக்ராம். ஓகேங்களா? இப்போ டேட்டாவை எடுத்துகிட்டு அப்படின்னா 4 பேங்க் இருக்குது, 16 16 பிட் ரெஜிஸ்டர்ஸ், அட்ரஸபிள் ரெஜிஸ்டர்ஸ் இருக்குது, 80 ஜென்ரல் பர்பஸ் ரெஜிஸ்டர்ஸ் இருக்குது. இந்த பேங்க்கில் எந்த பேங்க்கை நான் ஆக்சஸ் பண்ணுங்கிறது ப்ரோக்ராம் ஸ்டேட்டஸ் வேர்ட் அப்படின்னு ஒரு இது இருக்குது. அது வச்சா வில் பி ஆக்சஸிங் இட். ஓகே, அண்ட் திஸ் இஸ் bit addressable registers, and also you have 18 general purpose registers, right? So this is how it been appeared. So for calculating your program status word, the first thing is carry flag is available, auxiliary carry. F is nothing but user flag, and this is register select. So major part been given with 000, based on which your bank can be accessed. If it is 00, bank 0 will be accessed. If it is 001, bank 1 will be accessed. 10, bank 2 will be accessed. If it is 11, bank 3 will be accessed, and you will have an overflow flag. This bank space is X, where it is a don't care bit. There is no need to care about it. It can either be 1 or either can be 0 depending upon the applications. And the last part is parity flag. I repeat, CY is carry, AC is auxiliary carry, F0 is user flag, RS1 and RS0 are register select bank, and overflow flag, and this is X. Okay, PSW.1 is X, which is don't care, and the last which is parity bit. Okay, so this is how the program status word looks like. So yeah, I hope this video is informative enough. Added to that, I request you people to please go through Muhammad Masji for further theoretical knowledges. I hope enough information has been shared through this video. I request all of you to please write the same in your notebook for easy retrieval of data in the future classes. Thank you.